increasing and decreasing functions. If I draw for you now a cubic function, there is an x cubed graph. Yes? Typically they turn once. They turn at that point and they turn at that point. And when we talk about graphs, we talk from the negative x to the positive x value. When you discuss a graph, it's always from left to right. Yes? So if I start here, what's happening to the graph along that portion there? It's increasing. Here, there's one point when it stops, and then it is decreasing. And from that point on, it increases again. Yeah. So don't need to be Einstein now to work out where it's increasing, decreasing, and increasing. Yes? What we notice, though, is along the increasing side, yes, the slope of the tangent to the curve is what? Positive. At the decreasing side, what's the slope of the tangent to the curve? Negative. And when you're increasing again, what's the slope of the tangent to the curve? Positive. Right? So the first note we know is where a curve is increasing, yes, f dash x is positive. Yes? What do I mean by f dash x? I mean the slope of the tangent to the curve. Because we know that f dash x is the slope of the tangent to the curve. So if I asked you, prove it was increasing, you'd work out f dash x and show that it turned out to be what? Positive. Yes? The second thing we know is when a curve is decreasing, what do we know about f dash x? It's less than 0. It is negative. That's a negative slope. Here again, the graph is increasing. What about the slope? Positive. Do you understand that? At these 2 points, which are known as the stationary points, there's the slope of the tangent to the curve. Yes? And that point there is known as a stationary point. Stationary because the graph is neither increasing nor decreasing, and that's another stationary point. What's dy dx there? And what's dy dx there? Okay, well it's parallel to the x-axis. You'd agree with that? Yes? So the slope here is, it's parallel to the x-axis. So therefore it has the same slope as does the x-axis. And what's the slope of the x-axis? What's the slope of the x-axis? How would you find the slope of the x-axis? All right, I don't know what you had said. I presume you've said to me because it was hard to work it out. That's the x-axis. Well, if I took 2 points on it, 2, 0, and 7, 0, yes? Would you be able to get the slope of that axis now? Yes? And what would the slope be? y2 minus y1 over x2 minus x1. Where x1 is equal to and y1 is equal to and x2 is equal to and y2 is equal to. The point? 2, 0, 7, 0. So it's 0 minus 0 over 7 minus 2, which is 0 over 5, so the slope is 0. So therefore, dy dx, what's the slope of the tangent to the curve at these stationary points? 0. Yes? So the third thing you've learned here is, at the stationary points, you know that f dash x is 0. So to find these points, what would you do? Okay, you first of all, you find find f dash x, and the second bit is you do is you solve f dash x equal to 0. Because solving f dash x equal to 0 is you're calculating that point and that point. So let's go back over that slowly again for you. We talk about curves from left to right. Here a curve is increasing, then it changes it, decreases, and then it increases that again. Yes? It increases up until what point? Stationary point. That point, that stationary point, is known as a maximum turning point. They're not all maximum turning points. Then it comes down and it turns again. That's known as a what? A minimum turning point. And it decreases down to that, and then it will increase again. It won't turn again after that. What do I know about the slope of the tangent to the curve along the increasing section? It's positive. What's the slope of the tangent to the curve along the decreasing section? It's negative. And the slope of the tangent again is positive, again going from there on. Now, do you understand that to the theory? Because that will be the theory based on which we'll answer the rest of these questions. Yes? And there for you is an important page to have in